So when you look at Mars from Earth with a telescope, you can see the light red and then the dark patches. The red color is actually due to rust, iron oxide. So literally it is an old rusty planet. that's what it is. It's rust. Um, Oddly enough, and this is kind of interesting, when the planet is closest to us, it's harder to see it in detail. We kind of like it to be a little bit further away. Mars has seasons, just like Earth does. Right? We're tilted 23.5 degrees, Mars is tilted 24 degrees, so very similar with the seasons. And during the seasons, the ice caps shrink and grow, and they think the ice caps are made out of frozen carbon dioxide. The planet does get dust storms. So the Martian is not completely incorrect in the fact that, yes, they do get dust storms, just not as much force as what they would like to show you in the movies. And this is kind of funny, but when they used to look at Mars and they'd see the light spots and the dark spots, well, the dark spots are dark, right? And what are the dark spots on Earth? Forests. So it's like, oh, that must be the vegetation on Mars. Turns out it's not. All right, so if you can get the red colors, the features for the topography of Mars is actually quite interesting. You've got the southern hemisphere and the northern hemisphere, and they're very different. And right along this, you've got a boundary between the two of them. So the elevation change between the two hemispheres is about 4 kilometers over 100 kilometers. So it's kind of steep. I mean, not like mountain steep, but still it's interesting that there is this elevation. So the northern hemisphere actually looks like it's rolling volcanic plains formed by lava, volcanic rocks there. There's not many craters. And so if there's not many craters, they're thinking it's going to be younger. Because usually if it's crater covered, it's older in the original crust. If it's not crater covered, there's probably some sort of volcanic eruption that filled in the craters, thus making it younger. So they think the northern hemisphere is actually about 3 billion years old. And why the northern is covered by lava, they're not entirely sure. Now, the southern hemisphere is the exact opposite of the northern hemisphere. It's just craters. And so they think that this is no crust. Now in 1990, or 1990s, we sent a satellite to Mars to study it, and it came back with an image of a bulge. And again, here's that false coloring, right, where blue is deep and white is high. So you can quite clearly see the white Theris bulge on it. It's kind of exactly near the equator, rises up about 10 kilometers, and so if you were to consider continents, this is what they would consider to be the only continent. It doesn't have many craters on it, therefore they're thinking it's younger, 2 to 3 billion years old. And again, no tectonic activity. It's too small, cooled too fast for that. Valles Marineris. This thing is huge. It's a large canyon that cuts across a fifth of the planet, right along the equator. And unlike our Grand Canyon, which couldn't even be seen on here, our Grand Canyon is too small. It was not formed by water erosion. It was formed by the cracking of the crust, probably as the Theris bulge was formed. So the bulge came up, had to get its gift from somewhere, so it cracked the planet, a fifth of the planet. 120 kilometers wide, 7 kilometers deep, 4,000 kilometers long. There's other cracks on Mars. This one is just the big one. So you just saw a video of what it would be like if you were to fly through a part of the crack. Now, on the other side of the bulge is the Basin. Valles Basin. It's the lowest point on Mars, and you can kind of see that from the picture. It's the bluest, if you will. 3,000 kilometers across. 9 kilometers from top to bottom. So if there's bulge is 10 kilometers, this is 9 kilometers deep. Most likely it's due to an impact. They think it's about 4 billion years old. Again, that would kind of match up with the impact. When in doubt, it was a collision. There are other basins, one specifically at the North Pole. Again, probably a large impact, and whatever hit that was about 2,000 kilometers across. Unfortunately, I can't really see it on this picture. It's supposed to be the North Pole, and this only goes about 60 degrees instead of 90 degrees. Alright, so here is the volcano. The largest volcano in the solar system, Olympus Mons. 700 kilometers across. Right, that's the size of Texas. One volcano the size of Texas. It's also 25 kilometers tall. Right? There's bulge is only 10 kilometers tall. This thing is 25 kilometers tall. So again, all the volcanoes on Mars are not due to plate tectonics. They're actually shield volcanoes. Right? So same kind of thing as Hawaii. A hotspot plume underneath is erupting through the volcano. There's bulge has a lot of volcanoes on it. And there are some smaller volcanoes in the northern plains. And because of the cratering that we can see and the filling, we actually think that there's been eruptions as recent as 100 million years ago. So not quite a dead planet. Might be a rusty old planet, but it's not quite a dead planet. As I had kind of stressed, the volcanoes here are tall. Why? Because there's not as much gravity. Gravity pulls things down to the planet, and so in the case of Earth, it pulls rocks down heavy. But on Mars, there's only 40% of the Earth's gravity, so it doesn't pull it down quite as much, so that means that the volcanoes can rise higher.